Okay, ladies and gentlemen, we think that sitting down is the new smoking, so we're just going to put some tables up here and then stand here, because sitting down and looking at the audience is a little bit of a problem. We have a fantastic session. We're going to talk about infrastructure. What needs... Is this microphone working? Yeah. Can you hear me okay? Yeah. So first, because when they're building up, let me talk to you a little bit what we're going to discuss. We're going to discuss what kind of infrastructure do we need to basically build a sustainable future full of blockchain. What kind of platforms are there? What are we doing with energy? What are we going to do with identity? Yeah, I like that I have the mic, that would be fun.
Can you maybe take your dialogues outside so people can listen to him, yeah?
You can put me on there. So that's what I want to discuss with all of you. And we have a fantastic panel.
Details. Can you write down your email?
Sure.
And can you take your...
Can you turn the microphone of her off? That would be wonderful. Okay. Wonderful. So let me first, I'm going to have first a couple of talks, a couple of minutes talks with the individual panel members, because they are all extremely interesting people who all have a different kind of thing to look at this kind of infrastructure. And ladies and gentlemen, on the side here, speakers, can I ask you to get out or to stay? Thank you very much. That would be wonderful. So let me first introduce myself. I'm Vincent Everts. I'm a trend watcher. I've been involved since 2011 in this whole crypto world. And then somebody talked to me about it. It was about 7-8 cents. And I thought, like, oh my God, I've seen that all. You know, digital cash with David Chan in Amsterdam. I'm not interested. Next time it was €7. I bought 100 of them and then got slowly interested. I sold them when they were 700 a piece, and I bought a Tesla. I'm really into sustainable energy. I'm into the whole new mobility. And I sold my 100 Bitcoins. I've been organizing blockchain conference for the last 5 years, trying to get the old industry and the new industry to work together to say, hey, we need a new platform. We have new industries. We have a new way to organize trust. And we had every year, we have a different kind of discussion. It's a really interesting world. You know, last time ICO was exploding, and this year we're really getting sick and tired of all proof of concept. We really want to talk about what's for real. So that's about me. I'm really interested in all that new technology. But let's first talk about the speakers. I first want to ask John Savage to come to the stage and grab a microphone. And John has been in computer science for tens of years. I mean, like 40 years or something like that. Grab a microphone, John. I mean, he started MIT, Bell Lab, Brown. During your sabbatical, you went to the Netherlands and had a nice time there. He went from electrotechnical to computers. He says you need to educate something, so he did OS classes, operating system classes, algorithms, chip design. He made a chip silicon compiler, parallel computer, nanotech, cybersecurity, and now the last time crypto. And John, I want to ask you, of all your experience in the computer science industry, are we making the same mistakes all the time? And are we doing the same thing in crypto at the moment? What is your take of... How many years have you been now in the computer science industry?
Well, I've been at Brown University 50 years, and I've been in the field a little longer than that.
Yeah. So let me ask you, what kind of lessons can we learn and about all these other things you've seen coming and going?
Well, as you know, Bitcoin blockchains have a tremendous amount of potential, but I was struck by something that was said by a panelist on the previous panel who said, you should not care how it works. And my view is if you don't care how it works, it may not work the way you expect, and therefore you may suffer major losses. We've had some great examples of that. The DAO, the distributed, decentralized autonomous organization, hack resulted in the loss of $50 million, and that occurred because Ethereum is used as smart contracts, And the smart contract, there was a smart contract that had been written, which was executed in a parallel environment. And the authors of the smart contract thought it was sufficient to have a Turing-complete language, but they didn't understand that there are synchronization issues that arise with smart contracts. And if you don't know what you're doing, you may not do it correctly.
Yeah, I think he was referring to that as a user, we don't have to worry about TCP, IP, DNS, and all that kind of stuff. But I mean, it doesn't mean that you shouldn't be concerned about cybersecurity. Right. You have a certain responsibility yourself. But do you see that we make these mistakes all over again? I mean, that we design systems maybe for very small environments, and then they suddenly grow big?
They do. I mean, the internet was full of potential. It still is, and it's a great technology. But what we didn't appreciate is it was going to be a wonderful vehicle for cybercrime, and that it was going to allow the transmission of content to which some governments would object. They view that content as threatening. So what do? They then instituted controls. They are have attempted to get other nations to help them control the information that is received within their countries, their territories. And so before you know it, you've got international discussions of governance. Back in 1998, the Russians anticipated that cyber could be weaponized, and they brought a petition to the UN to address this issue. The United States wasn't interested at all in participating in those discussions, but within a few years, there were international discussions on this topic. Then the question becomes, if you're going to resolve international disputes, what mechanisms are you going to use to do that?
Yeah.
And so that's a governance issue. There is a form of governance that is very popular in the internet world, multi-stakeholder governance. You bring stakeholders together. And my concern about that particular form, which is used by the Internet Engineering Task Force, and which has been encouraged for use in the DNS system, ICANN, by the U.S. Congress, what worries me is what rules are you going to use, what constraints are you going to put on the person who convenes a meeting to ensure that the outcomes are going to be desirable. It's a very complicated subject. It's very difficult to get countries to agree on rules of governance.
Yeah, it's really, but crypto has been fantastic, about consensus mechanism, and suddenly now, things which were in politics or a little bit in economic games are now, into technology, and everybody becomes to talk about it. What kind of consensus mechanism are we using? And suddenly, the Dutch are also using the same thing. We always have all the stakeholders, we talk and talk and talk until we agree, and then we put it into law what we all agree about. But it's really interesting how that's now becomes much more prominent thanks to the crypto world.
Exactly. Well, we talk about blockchains and we say, well, obviously blockchains are immutable. I ask this question, is it obvious that blockchains will always be immutable? The consulting firm Accenture says no, and in fact they have been working with an Italian person, Giuseppe Attanasio, who's now at Stevens University, Institute of Technology in New Jersey, who has invented a type of hash function that can be unlocked, meaning the crypto blockchain is based on the use of hack functions. Mm-hmm. And these hack functions have the property that if you have you've produced a hash of, let's say, a set of transactions, it's going to be very difficult to find another set of transactions that when you hack it will give you the same hash value. Okay. The hash value is the secret.
Yeah, so we can design a system which is mutable and which has certain systems to be. Okay, we're going to discuss that a little bit more. Let me thank you for this introduction. Can I give my next guest, can I ask Makoto Takemiya? I'm doing a horrible job explaining that, or explaining it.
Hi.
But, hi. Very nice to meet you, all the way from Japan. And Japan is, of course, a very interesting society when it comes to cryptocurrency, because they have taken it into account in a very interesting way. They've made rules, regulations. It's been very popular. You're an American who basically because you don't exactly look Japanese, but you are. What's the story from you? You went from America to Japan how many years ago?
So I moved to Japan 10 years ago. I originally moved there to work on my master's thesis at NEC, and then after graduating, I worked in a neuroscience research lab for 6 years in Kyoto. And I liked Japan so much that I stayed there, and I got citizenship about 3 years ago.
Yeah.
As far as blockchain goes, while I was at the research lab, I was always studying new things. Actually, I saw Satoshi's original white paper back in 2008 when it came out in the fall, because I was studying economics and the global financial crisis at that time through my master's thesis on NLP, natural language processing. So I downloaded tens of millions of websites over a period of a few months. And actually, Satoshi's work was part of what was found in the crawler, and that's how I originally saw it. But I didn't really think much of it at the time. And then later, in about 2013, when it first kind of started shooting up, the price up to about $70, not yet $100 yet, I was like, oh, wow, this is interesting. And I started looking online, and there's Mt. Gox. You know, Mt. Gox is in Japan. As a Japanese resident, it's very easy to buy Bitcoin there. And so I got a few Bitcoins at, $100, $200. So not very much. I'm talking like one or two.
Yeah.
But then, Mt. Gox crashed, and then all these expectations and kind of faded, and winter came in a way, but still the community was still kind of there and submerged, and we kind of see that in the past year and a half. We've seen all these ICOs and new projects come. Suddenly, the market has found a new fit, a new way to reach new potential, and now it's back like 2013 again. Where
Yeah, and it's huge. I mean,
Yeah.
because a lot of the transactions happen in Japan. You worked on Hyperledger. You were very involved in that process. What part of the Hyperledger did you create?
Okay, so my company is called Soremitsu. We actually we have our logo in a few places. So we are a member of Hyperledger. We're one of the few startups in Japan that's a member. We created Hyperledger Iroha. Iroha is an open source blockchain. Anyone can take it, use it for free. There's no cryptocurrency associated with it. It's just pure technology. And we use it in our company. So we created this project from scratch. We use it in our services because obviously we need money somehow. So we do software development, system development for different people. Like the National Bank of Cambodia is our largest project right now. We're building a payment system for their country. In Japan, we're working with different insurance companies. We're doing, we have many different projects that we do.
Yeah.
But my personal goal has always been to kind of develop this technology as much as possible. So in Ethereum or IBM's Fabric or other platforms that are out there, you have to write smart contracts to do everything. We think that should be an option, that you should be able to write any arbitrary code if you want to, but it should also be easy to execute many predefined functions, such as creating assets or transferring assets. Verifying digital identity is a big use case that we care about.
So you're creator of the infrastructure, but you're also using it. So we're going to debate the different parts of the infrastructure. Thank you very much as an introduction.
Great, yeah.
Yeah, I will see you. We'll talk to you in 1 second. I'm going to have all the panel up and coming. I have to tell you that Professor Reza Abhari will join us in about 15 minutes, because he's now talking to the politicians and educating them, and he's running around from one to the other. Can I have my third guest, and that is Johann Gevers, creator of the Crypto Valley. And Johann, thank you very much for standing here. I mean, everybody from Switzerland knows Mr. Blockchain Swiss, but you're actually not very Swiss, are you, right? I mean, where are you from?
Originally from South Africa.
South Africa, and through all kinds of America, Canadian, blah, 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 you came here. When did you start to become involved in crypto?
In 2012.
In 2012, okay. Then the price was, what was it?
About between $2 and $5.
Yeah, so I bought him for $7, so he was before me. So that's really interesting. And you've done a lot of different functions. You try to connect people all the time. The crypto is, of course, the Crypto Valley is very, very close, but you're in the business of building ecosystems, and you've been touching a lot of different companies, right? And so can you mention a couple of them?
Yeah, I mean, I started Monetos in 2012, and as part of building Crypto Valley, I marketed the benefits of Switzerland to many different companies and helped them to set up in Switzerland.
Yeah. Okay. Also, we all know you because you were president of the foundation of Tezos,
Tezos.
which you cannot talk about because there's still a lot of good things going on. But I mean, that whole foundation thing has been happening. I just want to make sure, just for the record, you haven't left with a huge bag of Tezos and stuff, right? You left everything, and all the incentives you had for you as a president, you left behind, right? You're
Well,
really.
if there's a big bag, please tell me about it.
Yeah. No, so I just want to make sure.
I was not paid off to leave.
No, you were not. You left everything which there was waiting for you. You left. I mean, and Tezos you also went through what it is to drive a roller coaster to get the biggest ICO, and it goes up and down, and the money is everywhere. It's really hard to do governance and to organize something. I mean, I didn't know you, but when I heard about Tezos, I go like, my God, what's happening when all that money comes there? How do you organize that? How do you control that? It must be really hard. You have had that as a personal experience.
Right.
Is it hard?
Yes, definitely.
It is something to, so that's also, if we talk about the creating of the sustainable infrastructure, that's also part of it, that we need organizations which can handle the money. Can I have the other people also, my other panel members also come up, and then we're going to talk a little bit about how do we create an infrastructure which is sustainable. So let's start with that debate, gentlemen. If we're talking about 10 years from now, blockchain is going to be popular, it's going to be everywhere. In the previous panel, they talked about nobody will talk about blockchain anymore, just like we won't talk about TCP/IP and all that kind of stuff. What kind of infrastructure do we have at that moment? How can we build? How big will it be? And what will be the different parts of that infrastructure? Who wants to give a shot for that?
I'll jump in.
Yeah?
I think that even though this is called the Blockchain Summit, what I'm about to say is a bit of sacrilege. I don't think that blockchain is going to be the dominant part of the crypto space in the future. Crypto is really what it's about. There's a lot of technologies, even now, even today, there's a lot of technologies that are not blockchains, but that use cryptography. And that's really what it's about. The cryptography enables you to guarantee the integrity of assets and transactions. Blockchain is just one way of using crypto technologies, and it's not necessarily the best way of using it. It has certain use cases where it's great, but if you want to build a transaction platform, it's not the best solution. It doesn't scale, it's too expensive, it's too slow, and so on.
Okay. The future of blockchain is not going to be blockchain. What do the two of you think about? Who wants to jump in on that?
Well, I agree with your assessment about cryptography. It's certainly the applications that have the greatest potential use many more sophisticated technologies than those that are needed for blockchain. In fact, there are zero-knowledge proofs out there that are available. Anonymous identities are emerging. We need to secure communications, and we have the technology that we can use for that, which is used in blockchains, is the private key encryption technology, where every user has a secret key and they publish a private key. That was invented to solve the key distribution problem that we have with symmetric encryption, where every two pair of individuals has to have their own key, and they have to engage in an exchange of the key as well. Whereas with a public key crypto system, you publish your key to everyone, your public key, keep your secret, and then you can communicate. But it turns out that symmetric encryption is much more efficient. And so when we communicate securely over the web today, we first invoke a private, set up a secret key, or you can exchange public keys and use that as a basis for computing and then exchanging a secret key. So certainly there are many applications, I would agree, that extend well beyond blockchain.
The real innovation of blockchain and Satoshi Nakamoto's work was the creation of a digital way to do third-party accounting. So you have this third party, which is the system itself or the system participants, which are part of the creation of this ledger, when you send assets from one person to another, or any kind of state machine updates, so update to world state or localized state in one system. So from that standpoint, blockchain is not, requirement of this type of system. There's many different ways to do distributed or Byzantine fault-tolerant consensus, and blockchain being just one of them. That being said, and I think because of Nakamoto's original, proof of work, it uses lots of energy. So Bitcoin uses more energy usage than the country of Ireland, which is, huge, I think, a human travesty. But we're going to be able to make this more efficient. We're going to find new algorithms to do this, and using cryptography, we can, prove the provenance of all the data and who updated what state machine. Did they have the rights to do this? And blockchain is just kind of an overall framework for that.
Yeah, so blockchain is just one of the ways we basically can have this trust technology. I mean, and you don't even give it a big. You certainly don't think it's number one. I mean, you say the same thing.
Maybe just to correct that, I think it's an extremely important technology.
Okay.
But it's not everything. It's not the whole world.
No.
So it's one of many very important technologies.
Yeah, well, it's amazing how, it's interesting if you just have a technology and then you apply it to money and then suddenly everything is exploding, because that is basically, we were all excited about the technology. It was nice, it was beautiful, it was relatively simple, but then when the money came and we can model money and it works, then it's a huge fire which is accelerating that. So will that not be part of the future? Because the branding is huge.
Well, once there is a lot of value associated with some technology, there is always, we find that it's used in ways that were unanticipated. We humans are not good at anticipating the future.
Yeah.
So let me just illustrate a point. With these currencies, you not only have a mechanism for securing the blockchain, you need a way to identify individuals, but in addition, you have to have a network to share the transactions with one another. These networks are organized using what are called software protocols, and it turns out that miners, the people who collect the transactions and form them into blocks, miners have to connect with a certain minimum number and a certain maximum number of people on their network. Because of that fact, you can actually isolate a miner by taking up all the connections that they have to the network. And when you do, then you can disrupt the network in various ways. First, a selfish miner can block access to many other miners, and when customers can't find a miner to take their transactions, they can demand a higher fee. In addition, if you block enough miners, the miners who are not blocked can exercise enough computing power to launch a 51% attack and then change the chain of blocks, cause a forking, and cause a branch to be, of transactions to be orphaned, be avoided. So there are, this is a fairly subtle technology. The subtleties don't emerge immediately, but they do once.
You think there will be that kind of attacks in the future, right? I mean, we saw it a little bit with Bitcoin Cash, trying to get enough power, hashing power to influence it. But you think it will be more prevalent?
And let me say that for the internet, it had a similar amount of hype associated with it. We know that it's invaluable, and we're not going to live without it. But we never anticipated the myriad ways that it could be disrupted. And that's what we have to be on guard against in this context.
Okay.
I'd like to take your point a little further, John, and that is that human engineered systems in general tend to be fragile. And I think the physicist Stephen Wolfram actually made this point very clearly, that if you look out there at the natural world, the universe, the percentage of the universe that's predictable is vanishingly small. Virtually everything is chaotic in the sense of complexity theory. In other words, no matter how far our technologies go and how intelligent we get with AI and so on, we will never be able to predict the vast majority of what goes on in the world because it's a chaotic system.
It's true, but I mean, hey, listen, guys.
So-
I mean, we can say about.
Okay, let me just finish that thought. So what that means is that if we engineer the systems
Yeah.
with the assumption that we can predict, then we run into problems. And an example is the DAO hack that we had a couple of years ago, where they said code is law. Now, from an engineer's perspective, that's very enticing thought, but it's not how the real world works. So
Yeah.
getting back to your point, these unpredictabilities require us to build our systems in a way that if something unpredictable happens, we have a fallback system.
Yeah, we need
So-
more sophisticated governance on top of that, and then
Exactly.
I'm going to talk about that in a little moment. Can we move to some urgent subject, and that is the energy thing we were talking about? Okay, so we now have the most known blockchain, which does a couple of 100,000 transactions per second, and it uses the same amount as a country. And we have a system of governance that the people who control if new software which can take that problem away, because the problem is really not a big problem. We can easily design a blockchain which does 1,000 or 10,000 times less energy. But the problem is that software needs to be approved by those miners who are basically profiting from it. Is there any way in a system from governance that you say that we'll have a new algorithm, it will use 1,000 times less energy, and therefore all these miners, we don't need them anymore? Will that ever be approved? How are we gonna solve that problem? Because it's not a technical problem, it's more an organizational and political and a governance problem. It is it's actually a system which is designed by human and it has flaws, and how are we gonna correct that?
Well, I mentioned before the redactable blockchains, didn't I?
Yeah.
Okay, so that's one issue you can take, one approach you can take. But on the matter of energy consumption, if you can find a mechanism where people can make decisions, that they're reliable, honest decisions, but don't use a huge amount of energy, then that should be attractive. Now, there's a group at MIT, a research group headed by Silvio Macaulay, who has developed a new kind of currency with a new blockchain technology called Algorand. And that is based, as I understand it, on the concept that you have a lottery, you have a population of players, and some number of them are dishonest, but the number of dishonest people is, let's say, well below 50%. Then what you do is you choose, using a lottery system, players who are going to make decisions collectively, and you hope that statistically the people who have been selected to make decisions have a fraction that is honest, that's high enough so that when you can now use some, I don't know, Byzantine algorithm for making decisions, the right decisions will be made. That would be a way to obviate the need for all that electricity.
Okay. You want to say something about that?
Yeah, I was going to say that I think Satoshi Nakamoto gave us all an interesting hint as to what are the possibilities of completely decentralized systems in his proof of work. But it's kind of a prototype in a way, and technology never stops; it's always improved. So, in our blockchain that we created, Hyperledger Iroha, it's a permission ledger, but we don't have mining. We use something more like practical Byzantine fault tolerance. We actually use a slightly modified version that is made for our permission model. But in theory, though, you don't need to do all this mining. Actually, the bigger problem than energy usage in Nakamoto consensus is the lack of transaction finality, because of the probabilistic way that everything is created. This leads to high liveness, but you have maybe low amounts of consistency, or it takes longer to get consistency in the system. And so we make software mainly for businesses, and they need finality. They need finality instantly, so you get a supermajority of people validators that lock the transaction. Tendermint is actually a very interesting algorithm. A lot of people don't like it because it doesn't have as strong liveness guarantees. But it's a good way to make it so that you can lock a transaction and finalize it, and you don't need to have mining. You can use publicly available information. So, for example, the previous block cache, public keys of the validators, to determine who's responsible for minting this block or whatever. So there's many ways that you can do this, and I think
Yeah.
there's lots of really smart people working on this, so I think it's
Yeah,
something
but then you
that's
know the problem is, you will have 10 fantastic mechanisms for consensus which works wonderful, and you have another 10, and you have another 10. But the current blockchain is using a very energy, using mechanism, and the miners are in charge if new software is going to be adopted. So how are we going to get out of that mess?
That's quite simple. First of all, the miners are spending money, so spending money to produce the result, right?
Yeah.
They earn a certain amount of money for it. So if they can find a cheaper way to get that money, they're obviously going to switch. So it's in their interest to switch to a more efficient algorithm. That's one answer. The other part is if you can build that switching ability into the system itself. Now, Tezos is an example of that, where you can switch out from one system to another through voting by the miners and by the community. But more generally, if a particular blockchain or blockchain community is sitting on a less efficient or less effective system, you can simply start up a different blockchain.
No, that's the only way the
you don't
blockchain can slowly go away, the Bitcoin blockchain go away, and other ones are coming up.
Sure.
You're into Hyperledger, you're into research. I mean, we have all kinds of new platforms coming to the table. We have EOS who's trying something. We have Cardona or Cardano who's doing that. Do you see platforms which are the version 3.0 blockchain, which have all the problems solved? Do you see them coming to the horizon?
Well, someday you're going to have that. I think what you're going to see is that new ideas will be tested into so-called altcoins or other projects outside of Bitcoin.
Yeah.
And the really big ones, the really good ones, many of the ideas will be put into Bitcoin in the future, I think. It's going to take a long time, it's going to be slow, but eventually I think people are going to demand it because, the miners, they want to make money at the end of the day. If everyone is not using Bitcoin, the value is going to plummet and they're going to use something else. And so, but that being said, maybe there are structural problems in Bitcoin from an economic model. So by minting new coins only to certain people that do just one type of work out of many types of work that are good for the network, maybe that was a mistake. Maybe it should be, the economic model should be changed. And I think...
But you're positive, you're optimistic that all these ideas which we're trying out and all these altcoins will slowly make it to the mother of all change, all the blockchains, the Bitcoin one? So in 10 years, will the Bitcoin still be there as a dominant force, as a big one?
I think the potential is very high. I think projects like Ethereum are more at risk of disappearing. But maybe I'm wrong. So
interesting. Other perspective from that?
Yeah, I think the important thing is that one blockchain doesn't need to be used or be the best for everything.
No.
I think that's the key thing. That something that has been said about Bitcoin is that it's digital gold. Mm-hmm. Okay, so if you look at the world today in the traditional world of finance, gold isn't used for buying groceries. But that doesn't mean that gold is useless. People use it for other functions. They store it in a vault somewhere that's safe. It's kind of a risk hedge and so on. And I think that's probably the role that Bitcoin's going to play.
Okay.
And it doesn't necessarily need to evolve much to continue to play that role.
Okay.
And then other blockchains like Ethereum could be used for computation. And then when
do you see other platforms coming to the table?
Yes, absolutely. If you're looking for a different category, which is transaction efficiency, then you do not actually need a blockchain. Because let's just ask ourselves, what is a blockchain? Like
IOTA or something like that.
Yeah, I mean, there's kind of two categories of systems, both within technology and within society. The one is consensus systems, and then the other is transactional systems. Now, in a consensus system, we're here in Switzerland, if you take a vote about something, which establishes the rules for the society, then that's very expensive to do. We do it a few times a year. In other countries, you do it every 4 years. And it's very expensive because all the people in the whole community have to vote about what's going to be the rules going forward. Now, if you go to the grocery store to buy an apple or an orange, it doesn't make sense to ask the whole country to vote on whether you buy that orange and what the price should be. It doesn't make sense.
Yeah.
So that's a
So we need
individual
different
transaction.
blockchains for that. So can you
Exactly.
come
So-
up, because in the interest of time, I need to ask you, give me 2 or 3 names which you think are very promising technology, for that part of that industry for which we need.
There's a group in Eastern Europe. I mean, today everything's interlinked, but that's kind of the nexus, and they are building something that's not a blockchain.
Yeah.
That's more decentralized than a blockchain, but also very efficient, and it has better privacy and so on and so on. It's not open yet, but it'll probably be out there in 12 to 18 months.
Yeah. Well, for Internet of Things, we have IOTA, which we're basically studying, which also has it doesn't have a blockchain, but a thing like
I
that.
have a revolutionary suggestion.
Okay.
Cash.
Cash. Oh man, I hate cash. Oh, I hate cash with a passion. Okay, let's. You don't have a platform. You don't have a platform
No, I
which
don't.
goes further than cash.
No, cash is my solution.
Oh gosh, and that's really. I like that old.
Maybe plastic cash,
Oh, well, that's interesting. All my plastic is disappearing in this phone. I have all the cards are just slowly all getting in there.
Is it like this phone?
No, that's not possible with Apple. Apple doesn't allow you to do that. Just like only with Android. I can't wait to live without cash and without plastic. Okay, let's move to a different subject. Ladies and gentlemen, if we want a sustainable platform where we basically a blockchain or a variation of that has a role to play, we need one big problem solved, and that is identity. We need to get into identity. And identity needs to be a service which they can use. Can we start thinking about that? What is going to happen with identity in the blockchain? Who wants to give a try on that?
So our company's actually done quite a lot of work on identity. We're working on a mobile app right now called Yuna that will be out in a few months, and that's for managing identity with a mobile phone. So the idea, of course, is that your phone becomes kind of your key and your proxy for digital self.
Thank you very much for coming.
But
That's wonderful.
in the future, it'd be really great to go beyond this. So we've done a lot of research in the past year onto biometrics, and actually, we were able to, by coincidence, meet some really great people. And the outcome of all that research and work was that biometrics by themselves are not really secure enough because if you can record some data, everyone can record it, no matter what it is. So you have to go to some other second factor, and so we're actually doing research into implantable chips. I think we'll see more of this, where your body kind of becomes merged more with the technology. Your body can become the wallet itself, and that's kind of the end goal. That's a few years down the road, maybe, but it's where we're all going, I think. So that's my thoughts on identity.
Let me just quickly add that there is going to be a need to have many identity suppliers, and then you're going to need a system to integrate into a federated system all these identity providers. So there's another big governance issue emerging there.
Very important, yeah. Okay, we're going to discuss identity. We're going to continue discussing. Let me just introduce Professor Reza Abhari, who is a multifaceted personality from Iran, from America. I mean, and you have done anything from sociology to technology to political systems to modeling. And can you quickly introduce yourself, how you basically got there in this whole complicated road to crypto? And how you basically, where did you just come from? From which politicians was that? Where was that? Because you're running around doing a lot of different things.
Well, thank you very much. My apologies for being late.
No, that's fine. We know that.
It reminds me what you just said of what the Prime Minister May said. When you're from everywhere, you're from nowhere. So maybe that's where I am. I come from nowhere.
Cultural complexity, we call it, yeah.
My name is Reza Abhari. I'm a professor at ETH Zurich here, just down the road. And again, my apologies for being late. As I happen to coincide with today, we have something called Swiss School of Governance, where I talk about the future of infrastructure, resources, and technology. And we had a group of Beamte and politicians come up, so that's why I was there. So I took the opportunity to come here. My background is technology, but also finance and how they interplay with each other. So the role of really economic development, and so I have a strong background in technology. I have a group of about 70, 75 people. We do different types of activities, but What brings me here is a discussion I had about where I see the role of technology and communication as it refers to banking and central banks, and how different economic players were going to interact with each other in this new technology. I happen to advise also a number of multinationals and governments, so I see the point of view from practitioners, governments, and academics. So I was asked to come and give my point of view, so here I am.
Yeah, wonderful. So I'm just saying we're discussing now identity. If we talk about the infrastructure on blockchain of the future, one of the roles we need to integrate is identity. And that's what we're debating now, saying how do we get that? I mean, I think the perspective of having, getting as close to me as possible is very interesting. But what I'm looking for, I want to be in charge of my own identity. So it needs to be, I have my biological stuff, and I have something which I know and which I have, but I want to make sure that my identity is somewhere where I can enhance it from the government, from the telco, maybe from Facebook, from LinkedIn, from all kinds of different resources. Like you were saying, we need to manage that complex identity. How are we building a network, and how we're building a system which can integrate all these different identities? So maybe who can give us a shot on that one?
Sure. So the important thing is not to try and reinvent the wheel. There's a lot of study and a lot of work that's been done on identity, and the leading guy on that is Kim Cameron. He published the laws of identity back about 15 or 20 years ago, 7 laws of identity. And the first one you will like, it's about user control and user consent. So the user controls his own identity. And the other laws relate to not giving away more information for a particular purpose than what is needed for that purpose. You don't give away everything all the time.
Yeah, contextual identity.
Exactly, exactly. So I think what's important is that people inform themselves about what the state of the art is. So entrepreneurs that are now working on this should get in contact with Kim Cameron, and there's other people also that work with him. They've done fantastic work, and so that they don't forget some of the important elements. And one of the elements there is building an identity meta system, so that you have multiple different identity providers, but they are linked, in other words, they're made interoperable through this meta system.
Yeah. Professor Reza, do you have an opinion about how we're going to build that future infrastructure and have that complex identity, which you're really a good representative of, having part of different worlds? How do we make sure that we are in control of it and that we can organize it in a good way to have all these different identity providers integrated?
I want to just preface everything I said by start by saying that I am on the skeptic side. So
Good.
what I will say is more looking at how does reality and the politics are going to form what we do. The reality is there is no safe technology. It is practically impossible to make any technology safe. Often the population is told we can make it really, really, really safe. Yes, we can, but there's no 100%.
No.
And there's always somebody who
Safe enough. Safe enough.
Well, the question is who defines enough?
Yeah.
That is really the key question.
Yeah, if you ask the tax man,
enough?
you get a different answer than the man on the street.
Correct.
That's totally
so,
true. Yeah.
The element of trust, we can create 99.99% trust system, but we have to also acknowledge the 0.01% that will be broken by somebody. It's impractical to have a 100% trust system.
Yeah.
If we can accommodate that, the question is how do you manage the risk within that? How do you minimize the risk such that at the end the impact can be absorbed, both politically, economically, and it doesn't kill the industry? And I don't have a solution for that. There are other people who are more practitioners in how do you create this digital trust system. I mean, for example, John here gave us a wonderful lecture last night about how to do that, but even I think they acknowledge that you cannot create 100%.
No.
And the definition of what is enough, for me, is a question.
I would always say, if we're talking about digital identity, if we say it has to be 10 times better than paper, it should be easy to accomplish, right? I mean, John, you're into cyber security. The paper security normally is really bad, right? it's really unbelievable easy to treat people.
Not American currency. They put all kinds of little fibers in there, and you know, if your currency is suspect, they'll hold it up to light, and they'll have a, I don't know, a holograph in there or something. I'm not an expert in this, and I was joking about cash. I'm sure that digital currencies are going to be very important and probably be more widely used than credit cards.
Well, but I mean, I also want to, if it's about my identity, there's one thing, it's about money. I want it to be safe, okay? That's important. But if it comes to my identity and that I basically say all kinds of things and I agree to all kinds of things, then I want it to be very safe. I want that system to be better than a passport, which I'm now being used, or my credit card, or all kinds of other pieces of paper and plastic which are going to put it. So what is your thinking about that infrastructure in terms of identity, digital identity?
Well, let me put it this way. It's a good thing if you want to be assured that your identity is safe. It's a good thing you have a lot of friends. Because eventually, you know, we're all humans. And We're all going to require some human attestation to any truth that we want to promulgate. So we're going to have to rely on people in whom we have trust and who trust us.
So I want to jump in and to your challenge of how do we manage it and who defines trust. I think it comes back to something you said, Vincent, that it should be better than a passport and so on. I mean, when you look at driver licenses in the United States, just to use one example, every teenager there has a fake driver license.
Yes,
to get
everybody.
Into the bar.
Yeah.
So in other words, the traditional government identity does not work. I mean, it works.
It works good enough.
Works well enough, but it's really weak.
Yeah.
So we need something that's better than that. And the difficulty is that if you have only entrepreneurs developing solutions, but they are not accepted, then you can't get far enough. Then you don't have adoption. So you need both entrepreneurial solutions and you need government support for those solutions. So how do you do this without the government prescribing what the technology is? And the proposal that I push with regulators is that they should say, and this comes back to that there's both false positive and false negative error rates. And so the percentage of false positive and false negative for traditional identity is known. We know what that is for passports, for driver license, and so on. So what the government could say, and what they should do, is that they're not going to decide which technology is used. That would be a mistake. But they should say any technology that is better than
Factor of 10. Factor of 10.
Yeah. Than the traditional government identity is accepted, will be accepted by government. And that way you have competition between the innovators, the entrepreneurs, and it keeps getting better and better. Never be perfect, but it'll be way better than the identities we have today.
I think one important point is it is possible to create really good systems that are very secure, very safe. But you have to be careful about well, things like censorship and just becoming like a big brother police state. In Japan, there's a saying that fish cannot live where the water is too clear. And you know, you don't imagine life if, well, we're kind of that way already in some countries like Britain, where every action you take is kind of recorded somehow. Imagine once we get to AI processing all this, every action that you do will be known by someone. If you jaywalk, someone will know, or some entity or program will know. And that's not really a society that I want to live in, or anyone. So it's really important to, I really like Nakamoto's concept of pseudo-anonymity for interacting with each other, but we have to be careful about, you know, how do we go beyond that? How do we prove certain things about ourselves, but at the same time, not prove other things about ourselves?
Professor Reza?
We are at the nexus of multiple different players that are interacting with each other. You have governments, you have who sets the rules, you have individuals who want to participate, you have existing economic actors who want to maintain what they have, for example, banks. I can, for example, say that cryptocurrency is a direct impact on the business model of a lot of the banks. So, and then there are incoming players that want to participate in this.
Yeah.
Now, within that, we want to optimize, also maintain somewhat anonymity for private data protection. Well, if the economic distribution is large, different players are going to act in a different way. They're not going to necessarily be benign sitting there. Mm-hmm. So the notion that the technology is by itself is going to define a kind of a degree where we say it's enough is academic. As a professor, I can say that. The real question is what is politically accepted, where when you get incoming participants being challenged by the existing economic centers in an aggressive way, how would politically define, who will define, who become the arbitrator to say this is enough? Yeah. That I don't know who
in
that
a very international, very complex, with huge stakes, which huge stakes were on the board. Yeah.
And you have multi-sovereign states that have different intentions
right.
in there. So the notion that the technology would define it is not going to work.
Yeah, but you know, academics are always good to make it complicated. I now want to have a couple of simple answers. You know, I mean, I want to have a huge, interesting blockchain, which basically can run everything with a good identity, with security, and with privacy. And so far, you know, we're getting more difficult problems, and we have 5 more minutes left. Any questions from the audience which you'd like to solve? Can we have a question? Can we have a microphone over here? It will be. Let me see. Yeah, you can start talking, and the microphone will get to you.
Good afternoon. My name is Guy from Transfer Suisse.
Transfer fees. Yeah.
Yes. And I would like to know your opinion about quantum computer.
The quantum computer question
How does
always
it
comes
affect
back,
or helps or put in jeopardy the actual system that we have?
Very good.
Okay. There are only a few problems known for which quantum computing is known to provide an important gain over basic non-quantum computing. One of those is factoring an integer into its primes. There's another which is if you've got a list of unsorted elements and you want to find the largest or the smallest element, you can do that very quickly. But that particular problem can be solved in near linear time, analog n time, just by sorting. So personally, and I'm not very optimistic about quantum computing. Quantum requires that you create states which are entangled, that the entanglement lasts long enough, that there are enough what I call quantum bits, qubits, that you can to express your problem. For example, the factorization problem, if you start with a number that's 1,024 bits long, you're going to need 1,024 qubits. Right now, we can keep something like 50 qubits entangled for, I don't know, maybe 10 microseconds or something.
But John, let me ask you the question.
Therefore, I don't think the future is particularly bright for that.
Yeah, so the future is not bright, but what he, I think, wants to know is quantum computing going to decrypt everything very quickly? Is going to be a big danger for that? And the answer is no.
No.
Okay, good. Let me then, before we go to the second question, now that's also the academic and the practical. I'm Dutch, I really want practical answers. Let me then also, before we go to another question of the audience, is the future of blockchain, which there is not, if it's not about blockchain, it's about a lot of other things, but the future of blockchain, is it going to be private or public? You know, like the internet, you had private and public internet obviously one. Are we going to get huge public versions of blockchain, or is it going to be a total distributed field with lots of different options for lots of different things? Who's going to give us a take on that?
I think that the vast
vast
majority will be private, and a small, limited number of use cases will be public.
Is anybody another opinion on that?
I kind of think that all these different networks are going to be able to interoperate together, maybe through some public routing system. And that's kind of the system that we're building with IROHA. Is right now it's lots of private networks, but in the future we want to make it.
The internet is also a lot of different networks, but for us it's all the same. What do you think, Percy?
No, I agree. There would be a mixture of both. Exactly where the balance comes depends on really how the rate of adoption. I mean, this is going to drive that. I think blockchain technology will have, I'm positive of blockchain and somewhat cautious on cryptocurrencies. I mean, this is,
That's the more natural, normal,
Well,
what the industry thinks normally about it, right?
well, it's like governments are going to come after cryptocurrency. I mean, there's no question, so.
Okay. One more question from the
disagree.
audience. Who can I give the word to this beautiful panel? Okay. Then I'm going to ask a little bit more question. Oh, we have there.
I'm Fred from PwC. I would like to understand what you think about Lightning Network.
The Lightning Network as a solution for the scalability problem. Who wants to talk about that?
Sure. So the first thing is that Lightning Network, for those who don't know, is an off-chain solution that works with Bitcoin. And similarly for Ethereum, there's the Raiden network that does the same thing for Ethereum. So the key point is it is not a blockchain. It is an off-blockchain system that integrates with the blockchain.
Yeah.
And so, and that's precisely because blockchains are not efficient and are not scalable. So there's an off-chain solution that is efficient and is scalable. So that most of the transactions will actually be done in Lightning, and only a few transactions or settlement and so on will actually happen on the blockchain. So I think in principle that's definitely the right direction to go. Whether that particular technology is going to be the solution is an open question. There's both people who are for and against it. We'll have to see. At this point, it's experimental. We'll have to find out whether it works in practice.
Okay. And with this last question from the audience, I want to thank you very much for the infrastructure debate. I mean, I want to give a big hand to our wonderful public.